This extraordinarily generous donation from Chris Scott is an Amiga 2000 and some additional expansion cards, 102 RAM expansion, and this appears to be an accelerator with SCSI. I'm going to be taking this Amiga 2000 from dusty and neglected to almost pristine. So let's dig in and take this machine apart. Much of what's inside is not actually connected. The MFM hard drive here isn't connected to the controller card. This is an original A2090, which has both SCSI and MFM disk controllers. In fact, it's a A2090A as it appears to have the 3 ROMs required for auto boot. Inside of the case it's disgustingly dirty. We also have a 5 1/4 floppy drive. The only reason for that to be in the case is if at some point this had a bridge card in it, because the Amiga doesn't natively support a 5 1/4 drive. Removing the power supply, we are down to the bare motherboard, and it suffered some battery damage. And this 02 slot has seen better days. First, let's take the CPU out and clean up the damage. Remove any battery acid residue that might still be around. Pulling the power supply apart just to make sure there's nothing in here that's leaking. And it all looks reasonable. So for now, I'm not planning to do anything other than testing the voltages. We've got 12 volts, or close enough, minus 12-ish, minus 5, the 2.5 fluctuating is a tick signal, and everything else is 5 volts. Perfect. Everything looks good, so the moment has come to power this board on to see if it works. So for this first power up, we're just connected to the composite video out, which is black and white. We get a familiar Amiga Kickstart 1.3 screen, which on the recording looks like it's in colour, but I assure you it is actually black and white. Booting from the floppy drive, it's also working, and that gets us into Amiga test kit. The keyboard that was provided is pretty grotty, but it is incredibly working. The accelerator card is actually a 68030 running at 40 MHz, and the hard drive appears to want Kickstart 2, so let's put version 2 kick ROM in and it boots up into a desktop. Now those 2 hard drives I'm going to be imaging to give back to Chris. In the meantime, let's get back to the board. The first thing we need to do is give it a clean. We've already got rid of some of the green on the sockets, but the whole thing needs a good bath. So that's what we're going to give it. Everything's cleaned up quite nicely. We've removed the Zorro slot that was damaged, and we're going to be replacing that with something fitting, a gold-plated 100-pin Zorro 2 slot.
I love gold!
I'm planning on putting something quite special in this slot, so I really want to make sure that we have the best contacts possible. To make sure that Zorro slot actually works, we'll use the provided memory card. And yes, that's using something that's untested with something that's untested. But if it all works, it shows that both things are working. So the next thing to look at is the 23-pin RGB video out, which is damaged. The 5V supply and the 12V supply to the port have both blown. One because the trace, and the other because of the fuse. Fixing that and replacing the fuse, that gets us into colour. Oh, and once I've imaged the hard drive for the A2090, that's going to go to Glenn, or CRG, Casual Retro Gamer. There are some additional modifications and upgrades I want to do to this Amiga 2000. The first one being getting a CD-ROM drive working, then upgrading it to a full ECS chipset, including a full 2 meg of chip RAM, which, spoilers, doesn't go to plan, and results in some quite major surgery. And you'll get to find out why I'm putting an Amiga SCSI drive into a late 90s PC. But before we get to that, let's tackle the question of installing Amiga OS 3.2 from CD-ROM. What I've got on the bench is a bit of an Explorer setup. I've got the main board with a GVP 030 accelerator, which gives me SCSI and 16 meg of fast RAM. I'm using a 75GB SCSI disk and a 4x CD writer. There is a certain amount of charm to the sound and vibrations of a big old spinning magnetic hard drive. You can't beat a bit of spinning rust. The CD-ROM drive is attached, and we've managed to install Amiga OS, which was fairly painless. Now for the 2 meg chip RAM. I'm using the Ramesses 2, which is a solderless, and remember that, solderless expansion, to use the full ECS 8375 2 meg Agnes. After installing this, I was getting either a green screen or a yellow screen. Gary is not happy and is so loose I can just pull him out of the board with just my fingers, and Agnes is not looking much better. Applying pressure to the sides of the socket on Agnes, I can get different behaviour in diagram, suggesting the issue is contacts. It looks like the install of Ramesses 2 in this 30-year-old Agnes and Gary socket has proven too much. This solderless solution has turned into swapping out Agnes and Gary sockets. That's 84 pins for Agnes and 48 pins for Gary, making this a whopping 132 pin soldering marathon, beating the 100 pin Zorro 2 install hands down.
Fate, it seems, is not without a sense of irony.
You may have noticed that I've added a coin cell battery adapter and added the extra extensions to the two 8-bit ISA slots to bring them up to a full 16-bit capability. Okay, take 2 on Ramesses 2. Installation, this time with diagram installed. This confirms the existence of the 2 meg chip RAM. Thank Commodore, we can put this back in the box. But before I do, this board has no undershield, so let's build something to give it a little bit of protection. With the board back in, we're now on the home straight. Just the reverse of the teardown, with the CD-ROM drive in place of the 5 1/4 floppy. the addition of the accelerator and SCSI drive, the mouse I have works, but the buttons are a little sticky. So I'm just going to give them a quick clean. Now for that old SCSI drive. I need to image this to Chris. I went through a few iterations of hardware to get this drive to be visible. I also needed it to be able to run an OS that was new enough to be supported by Amiga forever, particularly the version that has the imaging functionality, but old enough to support a compatible SCSI adapter. My £3 PC to the rescue. It took what actually felt like 100 tries to get this drive to spin up and register. Once it did, imaging the drive was relatively simple. Now we've got an Amiga 2000 that's in much better condition, has SCSI, has an accelerator, has 2 meg of chip RAM and an ECS chipset. What I want to do is install this beautiful ZZ9000 card. Installing the card initially didn't fit and didn't actually work. Sponsors of this video are PCBWay. They provide PCB prototype fabrication from as little as $5. They also have a huge library of shared projects. And if you're not confident with a soldering iron, you can even get them to assemble them for you. PCBWay also have CNC machining and 3D printing services. All of this is available at PCBWay.com. Thanks PCBWay for sponsoring this video. I decided to add some more RAM, which went wrong initially. I did finally get it all working, and I finally got round to cleaning the keyboard. The ZZ9000 is an RTG card for the Amiga 2000, 3000 and 4000, as well as Ethernet networking and the ability to mount an Amiga partitioned USB drive. The ZZ9000 is a modern Amiga card using FPGA and ARM Cortex cores. In fact, it has 2 ARM Cortex cores with access to 1 gig of RAM. First off, does the Amiga still work? It's been a few weeks since I last worked on it. Well, it does. The next order of business is to make sure we've got space for the card. The ZZ9000 includes a flicker fix capability, so it connects to the graphics port using a long ribbon cable. Turning the Amiga on, we immediately get the boot options board information screen, and it's showing that this card is shut. That's because autoconfig couldn't fit it into the Zorro 2 address space, because our accelerator card is using a full 8 meg available on the Zorro 2 bus. By changing the jumpers, i.e. removing jumper 12, I can make it map all 16 meg as local RAM to the processor, freeing up the Zorro address space. This got me thinking, I can actually put the 8-up memory card in here as well. And that works, so now I've got an extra 2 meg of fast RAM alongside the 16 meg on the accelerator card, and I've got the ZZ9000 now showing up after it's been auto-configured. I want to test the 2 meg on the 8-up card because that's been in there for probably 20 years or more. The flicker fix capabilities are astounding. It's a beautifully crisp picture. So let's further demonstrate that. Here's the Shadow of the Beast. And I hope you'll agree the card itself is also quite pleasing inside the case. But we do need to address the fact that the card doesn't fit and I can't get the screw in it. So we're going to have to strip down the Amiga 2000 again. And while we're in there, we can solve some of the hacks that I did previously. You'll notice that the actual crystal on the accelerator card is being held in by some cork. Now that's not an ideal solution, and that's because the crystal falls out of the socket I put in. The reason the card didn't fit is the bottom tray that I created is actually too thick, and that's because this is a bit of a Frankenstein Amiga. It's a Rev 6 board inside a Rev 4 case. I don't think the Rev 4 case was shipped in Europe with an undershield in it at all. I do want some protection for the odd stray screw that will inevitably get underneath the motherboard at some point. So I've got a thinner piece of plastic which shouldn't cause the same problems putting the cards in. Assembling this, you'll notice I've put a new socket in for the crystal, and turning it on would actually help if we connected the SCSI cable. Take 2, it all works. Here you can see Lotus Esprit Turbo Challenge 3 intro and the demo again just showing off the flicker fixing capabilities of the ZZ9000. I want all these backplates to be nice and clean, so I'm putting in black ones. And there we go, all back in the case. But I still need to clean the keyboard, just with general cleaning products and then followed with a bit of isopropyl alcohol. This is not retrobrighting it, but it's improving it from what it was to something that I feel at least safe using. Altogether, it's looking good. But we need to explore RAM. We've got an 8-up card with only 2 meg on it. Searching around, these exact chips aren't available. I did find a post which showed these pictures of the card with 81C1000, which is a fast page RAM, and apparently that's compatible. And I can get these on AliExpress for £2 for 5, so I grabbed some while they were available. Putting them into the card, an additional 2 meg at a time, it showed errors with just the first 2 meg added, so 4 in total.
Face I ever got. God damn it! Son.
But it turned out to be entirely my own fault. In installing one of the chips, probably without glasses on, I'd bent a pin.
Oh, well, that's all right then!
Putting in another 2 meg, bringing us up to 6 in total, we're going to boot up into Amiga Test Kit using an external Gotek drive. This is so we can run memory tests on the 8-up 6 meg. Thankfully, this memory passes the tests. Following the triumph of getting RTG card installed, we're going to put in 16-bit audio into the Amiga 2000 and see if we can get MPEG-3 playing from a zip disk. And I also need to sort out why you have to bang it on the top like the fonts to get it to work. The MNT ZZ9000AX is an audio expansion for the ZZ9000. MNT never cease to amaze me with the level of detail they go to with their packaging. The package includes the ZZ9000AX card, stainless steel slot bracket, mounting screws and nuts, and all of the cables required to connect it to the ZZ9000 RTG card. The first thing we need to do is remove the ZZ9000 from the Amiga 2000. I've been having concerns about the amount of heat that this hard drive is kicking out. You'll notice that I've moved the ZZ9000 card to a different slot, and that was just to get it away from the heat of the hard drive. For aesthetics, it would have been nice if this card was available in black to match the ZZ9000. The instructions are fantastic. It provides full colour pictures. The hardware installation itself is very simple. Using the pictures as a guide, it's quite easy to get the orientation of these correct. The Sigma DSP audio chip on the ZZ9000AX is an Analog Devices AD-AU1701, featuring a 28 MHz 56-bit Sigma DSP for digital audio processing. There we go, that's the ZZ9000AX all hooked up. All we have to do now is put it back into the Amiga. Because I'm starting to learn not to put the top back on my Amigas before I've got it working, let's get the drives installed while we're still on the bench. Okay, the Amiga boots, that's a good start. Attaching the external Gotek and using the ZZ9000 install utilities disk image, running ZZ top shows the ZZ9000AX is in fact detected. Installing the drivers is pretty simple. Just follow the on-screen instructions and install the drivers that you want. This package includes everything for the retargeted graphics, network and the ZZ9000AX expansion. This also includes hardware MPEG-3 decoding. Because I'm going to use a zip drive, I'm going to copy the zip PC from the PPA zip project and change the device to use the GVP SCSI. Inserting the zip disk that I used in my other experiment with the zip drive, I've got worms! Now I've proved that the zip drive actually works, I can use that to transfer MPEG-3s to the Amiga 2000. The software installed uses AHI. I have the version 4.18 installed. Choose the ZZ9000 setting. And point Amiamp at the MPEG-3 decoder. And we have horrible background noise.
I know that sounds bad.
After a restart, doesn't sound a lot better.
Right, that's bad. Okay.
Turns out it's actually that internal audio. The floor of the Amiga 2000 cable being strewn across the case means there's too much interference to use it. With that internal cable disconnected, you can hear it playing in the background with no horrible hiss. Switching to the direct input. Near perfect MPEG-3 audio from Amiga 2000 with a 68030 running at 40 MHz and a couple of ARM Cortex cores. Because it has an auxiliary input on the back using two RCA connectors, jumping those round to the outputs on the Amiga bears fruit. So we now have pass-through audio without using the internal connection. Not ideal. From an audio quality point of view, absolutely superb. Just to make sure, let's check we can still play MPEG-3s with no background noise.
Yay!
In an attempt to solve the heat problem caused by the hard drive, I removed it from the accelerator card and temporarily relocated it. Removing the weight of the hard drive from the accelerator card had an unexpected side effect. You can hear the drive sticking. You can see the little green activity light on the ZZ9000. Take hand off. Stopped. Pressure on the card slot. Hear it ticking again. So we have dubious connectivity on the CPU port, which I've suspected for a while now. You shouldn't have to bang it on top like the fonts to get it to work. But before we do, it's time to finally face the future of vintage computer storage. This is the blue SCSI. This kit doesn't need much assembly, and it comes with a really nice sticker. This is a SCSI drive out of my Amiga, a piece of spinning rust that's causing me some huge thermal problems.
It's hot! Damn hot!
As much as I love the sound of this drive, hearing it click and chirp in its spinning rusty way, It does kick out a lot of heat inside the Amiga, which was never designed to run at the temperatures this drive appears to want to.
Fool, what is hot? I told you again, where you born on the sun?
It's a 73 gig drive, so I'll have to find a 128 gig SD card. And the aim here is to use the blue SCSI in its initiator mode to image this drive to that SD card. And to do that, we're going to need some power. I'm going to use this ATX power supply, using my nice adapter, which has an on-off switch, to power the SCSI drive and the blue SCSI board. Putting these two on the same SCSI bus, I have downloaded the latest version of blue SCSI firmware. You do that by connecting the Pi Pico to my bench PC, holding down the button and dragging and dropping it straight onto the Pico. We then need to set up the SD card. The first thing we need is a blue SCSI ini file which has the configuration in it. Well, for some strange reason I managed to miss off the terminator jumper and the other initiator jumper. After adding those two, I could actually set the prod properly into the initiator mode. It took all night to image, but let's try that image in WinUAE. By taking one of my existing configurations that mimics my Amiga 2000, I can simply remove the existing drives and add in the freshly created image, making sure it's read-only of course, because I don't want to corrupt it should anything go wrong. Ejecting the floppy disk in the emulator, and then quickly saving this configuration before we start the emulation. Well, that's a success. Now to get the Amiga 2000 back together again. But I have encountered another problem. The power supply now appears to have died. As you can see, I've done some work on it already, and that's because I was simply going to replace the fan. I didn't test before I started that journey, but it definitely doesn't work now. I've replaced one of the caps that looked a little bit suspect, but it still is very much dead. I'm replacing the voltage comparator and the strobe controller. These are relatively cheap items. They don't cost any more than a few pence, so replacing them isn't a big deal. So I'm just replacing those two ICs with sockets and putting new ones in to see if that solves the problem. I soldered it all back up, tested, it still didn't work. I've taken this little board off again, and we're going to test every single component on it. This again had absolutely no bearing on the problem. I'm not making a huge amount of progress, so I've decided to recap the entire power supply. After recapping it, it worked for approximately 15 seconds before something else catastrophically failed. The parts that haven't been replaced on this power supply so far are either unknown or unobtainium. So this compact HB 146 SNQ power supply to the rescue. It's an ATX power supply of rare proportion, in that it actually has the -5 volt line. And size-wise, it's almost identical to the Amiga 2000 power supply. So I'm going to start by completely stripping down both power supplies. Because the Amiga 2000 power supply is in fact factory set to 230 volts because it's a European model, I'm going to do the same to the ATX power supply. Open on this connector means that it's set to 230. Because the ATX power supply, or Advanced Technology Extended, uses a PS on signal, which is effectively a pulled high line that in order to turn the power supply on has to be pulled low by the motherboard. By putting a switch between these two is signaling the power supply to turn on. I'm going to use the original Amiga 2000 switch to do that. On this particular power supply, the PS on is actually white, and I'm going to use the ground that's nearest to it, which is fairly common practice, and in this case it's a black wire. You might find that other ATX power supplies, the colours of these wires are slightly different. The PS on is often green. I'm using an old SCSI drive that may or may not have come out of an Amiga at some point as load for the power supply. This should give me a better 5 volt line. I've always considered that pretty much plus or minus 10% on the 12 volt line is relatively safe, but I wouldn't want to be on the high side. 11.24 is a little bit low, and some people will probably argue in the comments that this power supply is on its way out, and it might be. The main thing is that the 5 volt line is bang on. Well, that's the power supply all buttoned up, with some nice new hardware, because some of the screws were getting a little bit gnarled up, given the number of times I'd had to take the case off. Let's put it in the Amiga. So while I've had the board out, I've taken the opportunity to do a better cleanup on the acid damage. I also need to replace the battery. The one that's in it I found in another motherboard. I've gone to the trouble of putting a battery holder in it. It wouldn't make sense to actually have a battery with some power in it. Seeing as I've removed the hard drive, I don't need this huge bracket attached to the accelerator. I'm replacing it with a 3D printed backplate provided to me by my sister.
That says master, does it? Well, I should really change that to Petit Diablo.
Even with the slightly damaged backplate, this should still hold the card in quite nicely. Okay, test kit can see the accelerator, so let's get the keyboard hooked up. There should be 16 meg on the accelerator card, another 6 meg on the 8-up card, and an additional 1 meg of chip RAM. None of that's been seen. This doesn't make any sense. It looks like we're going to have to take the Amiga apart again and try and diagnose what's causing this problem. So I started looking at this, and we've definitely got a problem. So if I come down here, 33, 34, 35, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, which is address 20, I think, is attached to 21. Which isn't a good thing at all. We've got a short across 2 address lines, and we can see the same thing on Gary. The same 2 address lines are shorted. I'm guessing this has happened when I've replaced the CPU slot. There must be a short on the back, or could be 2 lines that are really close and I've bridged them. If you look here, there's a human hair width slither of metal joining the 2 pins together. This actually looks like it could be something that's shaved off the pad or via, or it could be a piece of solder braid. After removing it, I don't have a short anymore, and we've got 2 meg of chip, 6 meg of fast, and we can see all the Zorro boards. And now I've got a different problem with the output from the ZZ9000. And don't forget, I've got no tick signal anymore, so this is just jumpered with a signal from Agnes.
Hang on a minute, lads. I've got a great idea.
I've knocked together my own 50 Hz generator using a 555 timer, a couple of capacitors and some resistors. It ain't pretty. The question is, does it actually work? And the answer to that question is yes. Yes, it does. And just to prove that, let's have a look at the intro to Lotus 3, the ultimate challenge. The output from the ZZ9000 flicker fixer might actually be even better than it was before. Also, let's see if we can do a better job with the tick generator. This easy to assemble project is simply a reimagining of my original hacked together 555 timer solution. It's called Jazzstick because it's good enough for jazz. And it's not an exact science. Rather than taking a single resistor, it takes 4. This is to allow you to fettle the resistance a little bit to tune it to the right frequency. I'm looking at using 100 ohm and 150 ohm resistors. The actual value required could be anywhere between 350 and 550 ohms. what I'm aiming for is 50 Hz. That's because I'm in the UK and I have a PAL Amiga. So the first pass isn't quite as we expected. So it takes a little of trial and error. What I've ended up with are 4 100 ohm resistors, so let's just take a moment to see what the values actually are and what our total resistance is. Now that's more like it. It's entirely possible to get this to generate a 60 Hz signal if you want NTSC. Let's swap this out with the hack we have in the Amiga. Well, you can see this nice new board is now stuck to the power supply, a little bit like a tick. And I bet the question you're asking is... Now, to address the disaster with the bracket my sister made for the GVP accelerator, we're going to have another attempt at mounting the GVP, and the blue SCSI can be mounted much better than it is. My plan is to take these freshly created 3D prints and spray them black, so they fit in much better with the aesthetic of the Amiga. And to be honest, I don't like the really weird powder blue colour. Now everything's completely dry and glued, we can start putting these together. As the accelerator currently only has the EC version of the 68030, I've got no MMU. So I'm going to replace it with a full ceramic version with an MMU. And a much more pleasing aesthetic. Hopefully you agree that's a vast improvement.